Are you new to manual testing or preparing for a QA interview and not sure where to start? Don't worry. In this video, we're going to cover the most important manual testing concepts step by step, from the basics of software testing to real-world testing scenarios. So grab your notes, stay with me till the end, and let's make manual testing really easy to understand. Let's get started. First, let's quickly see what we're going to cover. We'll start with the basics of software testing and understand why testing is important. Then we'll move into SDLC and STLC, testing principles, testing levels, and different types of testing. We'll also cover test cases, defects, Agile and Scrum, and some practical testing scenarios. So let's start with the most basic question. What exactly is software testing? Software testing is the process of checking whether an application works as expected and meets its requirements. We compare the actual result with the expected result and identify any defects. But testing isn't just about finding bugs. It's also about improving the quality, reliability, and user experience of the application. For example, in an e-commerce application, we test login, search, cart, checkout, payment, and many other scenarios. So, why is all this testing actually necessary? Testing is important because it helps us find defects before they reach real users. It helps verify business requirements, reduce production failures, and improve the overall quality of the product. Think about a payment application where the payment suddenly fails after release. That can directly affect both customers and the business. That's why we test different scenarios before release. Now let's understand where testing fits into the overall software development process. SDLC stands for Software Development Lifecycle and describes the overall software development process from requirements to maintenance. STLC stands for Software Testing Lifecycle and focuses specifically on testing activities. It includes requirement analysis, test planning, test case design, environment setup, test execution, and test closure. So, testing is not something that happens only at the end. Next, let's look at two important concepts: verification and validation. Verification asks, are we building the product right? It mainly involves reviewing requirements, designs, and other documents. Validation asks, are we building the right product? Here, we actually execute the software and check its behavior. For example, reviewing a requirement document is verification, while testing the actual login functionality is validation. These two terms are very common in interviews. Moving on, let's look at some important testing principles. There are some basic principles every tester should know. Testing can show the presence of defects, but it can't prove that the software has zero defects. Exhaustive testing is also impossible, so we focus on important and risky scenarios. Testing should start early because finding defects earlier can save time and effort. We should also keep improving our test cases instead of running exactly the same test repeatedly. Next, let's understand the different levels of testing. Testing can be performed at different levels. Unit testing focuses on individual components. Integration testing checks whether different modules work correctly together. System testing focuses on the complete integrated application. And acceptance testing checks whether the application meets business and user expectations. So, the scope increases as we move from individual components to the complete application. Now, let's see the difference between functional and non-functional testing. Functional testing checks what the application does, for example, login, search, checkout, or payment. Non-functional testing checks how well the application works. This includes performance, security, usability, compatibility, and reliability. So, checking whether login works is functional testing, while checking how many users can log in at the same time is performance testing. Both are important for a good quality application. Now, let's move to two testing terms that are often confused: smoke and sanity testing. Smoke testing is a broad but shallow check. When a new build is received, we quickly test the major functionalities to see whether the build is stable enough for detailed testing. Sanity testing is more focused and is usually performed after a specific change or bug fix. So smoke testing gives us a quick overall check, while sanity testing focuses on a particular area. Now, let's look at another common interview topic: retesting and regression testing. Suppose a developer fixes a login defect. First, we perform retesting to check whether that particular defect has actually been fixed. Then we perform regression testing to make sure the change hasn't affected existing functionality. So, So, retesting focuses on the specific fix, while regression testing checks the impact of the change. This difference is very important in real projects as well as interviews. Next, let's understand test scenarios and test cases. A test scenario tells us what we need to test. For example, verify login functionality is a test scenario. A test case explains how we are going to test it, including steps, test data, expected results, and other details. So, a scenario is high level, while a test case is detailed and executable. Once we understand this difference, the next question is, what makes a test case a good test case? A good test case should be clear, concise, and easy for another tester to understand. It should be linked to a requirement and should have a clearly defined expected result. We should also cover both positive and negative scenarios. For example, for login, we can test valid credentials, invalid credentials, blank fields, and other relevant cases. Good test cases help us achieve better coverage and make testing more consistent. Now let's see what happens when we actually find a defect. When a tester finds a defect, it goes through a defect lifecycle. It may start as new, then get assigned to a developer. After the developer fixes it, the tester performs retesting. If the issue is fixed, the defect can be closed. If the issue still exists, it can be reopened. Depending on the project, we may also have statuses like rejected, duplicate, or deferred. Now, another very common interview question is severity versus priority. Severity tells us how much impact a defect has on the application, while priority tells us how urgently it needs to be fixed. For example, a small UI issue on a payment page might have low severity, but the business may still give it high priority because payment is important. So simply remember, severity is about impact and priority is about urgency. Now, let's see how we should report such a defect properly. A good bug report should be clear enough for the developer to understand and reproduce the issue. It should include a meaningful title, environment, preconditions, steps to reproduce, expected result, actual result, and severity or priority when required. We can also attach screenshots, videos, logs, or error messages. A clear bug report saves time for both QA and development. Now, let's move from testing concepts to something you'll commonly see in real projects, Agile and Scrum. In Scrum, the product owner manages business requirements and priorities. The Scrum Master supports the Scrum process, while the development team works together to deliver the product. Common Scrum events include sprint planning, daily Scrum, sprint review, and sprint retrospective. As a QA, you're involved throughout the sprint from understanding requirements to testing, reporting defects, retesting, and regression. Now, let's apply some of these concepts to a real-world scenario. Imagine you're testing an application and suddenly the login functionality fails. First, reproduce the issue and check whether it happens consistently. Then verify the test data and environment. Compare the actual result with the expected result and collect useful evidence. If it's a genuine defect, report it clearly. Once the developer fixes it, retest the login functionality and perform relevant regression testing. Now, let's take another important real-world scenario: payment failure. Suppose a payment fails while testing an e-commerce application. First, check the payment amount, payment method, test data, and environment. Verify the error message and collect evidence. If required, check network or API responses to understand where the failure is happening. Then report the defect with clear steps and business impact. After the fix, retest the payment flow and perform regression testing around related areas. Now, let's quickly revise some questions you should be ready for in an interview. Some common manual testing interview questions include: what is STLC? What is the difference between smoke and sanity testing? How is retesting different from regression testing? What is severity versus priority? And what is a test scenario versus a test case? You should also be ready for practical questions like: how would you test a login page? Don't just memorize the definitions, try to explain your approach using real examples. So, what makes someone a good tester? A good tester doesn't simply execute the given test cases. They understand requirements, think from the user's perspective, identify risks and edge cases, and report defects clearly. Most importantly, develop the habit of asking, what can go wrong here? This mindset helps you discover scenarios that may not be directly mentioned in the requirements. And with that, let's do one quick revision. Let's quickly revise the key concepts. Software testing checks whether an application meets its requirements. SDLC covers the overall development process, while STLC focuses on testing. Smoke is broad, Sanity is focused. Retesting checks a specific fix, while Regression checks existing functionality after changes. Severity represents impact, and Priority represents urgency. These are some of the most important concepts you should be comfortable explaining in a manual testing interview. And that brings us to the end of our complete manual testing guide. We covered everything from software testing basics and STLC to test cases, defects, regression testing, agile, and real-world scenarios. If you're preparing for a QA interview, save this video and revise these concepts regularly. And if you want to learn more about software testing, Selenium, TestNG, Cucumber, Java, and automation testing, make sure to subscribe. Thanks for watching, and I'll see you in the next video.